Electronics for all. Be warning. This video for scientific only. Be careful if you try to do it at home. A good day for all. This video tutorial is about the most important circuit in electronic design and while working with electronics. We often find ourselves in situations where it becomes necessary to step up the output voltage while the input voltage stays low. This is a type of situation where we can rely on a circuit that is commonly known as the boost converter step-up converter. A boost converter is a DC to DC type switching converter that steps up the voltage while maintaining a constant power balance. The main feature of a boost converter is efficiency, which means we can expect long battery life and reduced heat issues. So, in this article, we are going to design a TL494 boost converter and calculate and test a high-efficiency boost converter circuit based on the popular TL494 IC, which has a minimum supply voltage of 7 volt and a maximum of 40 volt, and as we are using the IRF3205 MOSFET as a switch, this circuit can handle a maximum current of 19 amperes, theoretically limited by inductor capacity. Finally, there will be a detailed video showing the working and testing part of the circuit, so without further ado, let's get started. To understanding the working principle of the boost converter. Figure 1 shows the basic schematic of the boost converter circuit. To analyze the working principle of this circuit, we are going to divide it into two parts. First condition explains what happens when the MOSFET is on. The second condition explains what happens when the MOSFET is off. Now, what happens when the MOSFET is on? As shown now, the condition of the circuit when the MOSFET is on. As you can recognize, we have shown the on condition with the help of a dashed line. As the MOSFET stays on, the inductor starts charging. The current through the inductor keeps on increasing, which gets stored in the form of a magnetic field. What happens when the MOSFET is off? Now, as you may know, the current through an inductor cannot change instantaneously. That is because it's stored in the form of a magnetic field. Therefore, the moment the MOSFET turns off, the magnetic field starts to collapse, and the current flows in the direction opposite of the charging current. As you can see, this starts charging the capacitor. Now, by continuously making the switch MOSFET on and off, we have created an output voltage that is greater than the input voltage. Now, we can control the output voltage by controlling the on and the off time of the switch, and that is what we are doing in the main circuit. Now, before we going to build the circuit based upon the TL494 PWM controller, to learn how the PWM controller TL494 works. This IC has 8 functional blocks, which are shown and described. The IC has 2 internal output transistors which are in open collector and open emitter configurations, by which it can source or sink a maximum current up to 200 mA. Note: the transistors have a saturation voltage of less than 1.3 volt in the common emitter configuration and less than 2.5 volt in the emitter follower configuration. The circuit diagram for high-efficiency boost converter shown. This TL494 boost converter circuit is made up of components that are very easily obtainable. And in this section, we will go to explain the main circuit. How TL494 boost converter working. This TL494 boost converter circuit is made up of components that are very easily obtainable. And in this section, we will go through every major block of the circuit and explain every block. The input capacitor is there to serve up the high current demand that is required when the MOSFET switch gets closed and the inductor starts charging. The feedback and the control loop. Resistors R2 and R8 set the control voltage for the feedback loop. The set voltage is connected to pin 2 of the TL494 IC. And the feedback voltage is connected to pin 1 of the IC labeled as voltage feedback. The resistors R10 and R15 set the current limit in the circuit. Resistors R7 and R1 form the control loop, with the help of this feedback. The output PWM signal changes linearly, without these feedback resistors. The comparator will act like a generic comparator circuit which will only turn on/off the circuit at a set voltage. Switching frequency selection. By setting the proper values to pins 5 and 6, we can set the switching frequency of this IC. For this project, we have used a capacitor value of 1 nanofarad and a resistor value of 10 kilo ohm, which gives us approximately a frequency of 100 kHz. Testing this high voltage boost converter circuit. To test the circuit, the following setup is used. As you can see, we have used the PCATX power supply as input, so the input is 12 volt. We have attached a voltmeter and an ammeter to the output of the circuit, which shows the output voltage and output current, from which we can easily calculate the output power for this circuit. Finally, we have used 8 4.7 ohm resistance 10 watt power resistors in series as a load to test the current consumption. The test showed that the circuit is working good with stable conditions. Note that, use a good area heatsink to avoid any damage for transistors, and use the original parts to avoid any damage to your own circuits. Finally, download the data sheets of the main components to check all of the specific requirements you need in your own circuit. This video is a tutorial, and this circuit is a basic circuit that's need more additional components to be a more efficiency. Stay tuned for new videos and more tutorials. Thanks for watching. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.